Look at your notes. Okay, your homework 3 that you just picked up is due next Friday, not tomorrow. So the only homeworks that are due tomorrow are 1 and 2. 1 and 2.
Today's Thursday. Wow.
Today's Thursday. Okay, so ideally, if we don't take 100 years, like we're already doing right now, okay, then we'll have time to look at the homework, and if you have questions, you can ask them in class.
Okay, sir.
Okay.
Don't mess up today.
So,
Through all of them and just do it by yourself.
no. Okay. Yassine is ready?
Yes.
Okay, this is called a definite integral. Okay, now what is different from this integral compared to the ones we've been doing the rest of the week? You see these little numbers? Here and here, here and here. Okay, that's what makes the integral definite. All the other ones we've been doing have been indefinite integrals. Okay, so a definite integral represents the amount of area enclosed by the x-axis and the function f of x on the interval from a to b. Okay? So all that you have to do is sketch the graph, then shade between the x-axis and the graph, and then find the area. Okay, so today should not be like a super hard, you already know how to find area, hopefully. Okay, it should be like a nice day. Okay, so we're ready to do number 1. Okay, what is my equation? Look in the middle. 2x. What does y equals 2x look like? Okay, it's linear. It starts where? At 0, 0. What's the slope? 2 over 1. So I'm going to count up 2 over 1, up 2 over 1, up 2 over 1, up 2 over 1. Okay, then I can go the other way, down 2 backwards 1, down 2 backwards 1, down 2 backwards 1. There we go. Okay? Now, what you need to do next is shade between the x-axis and the graph. So, I'm only going to do it from the endpoints on the integral. So, the first value I'm going to start at is 0. I'm going to shade until 4, but I have to stay between the x-axis on bottom, the function on top. So, 0 is here. I'm going to shade all the way until 4. Okay, so let's look again at the integral. Okay, I'm going to start at x equals 0, and I'm going to stop at x equals 4. That's what these numbers stand for. So the lower number is where you start shading. The upper number is where you stop. So you see these right here? Start, stop. So I started at 0, I stopped at 4. Okay, and then we're going to find the area. What shape is that? Okay, triangle. How do you find the area of a triangle? Okay, 1/2 base times height. How long is my base? 4. How tall is my height? Height is 8, so it'd be 1/2, 4 times 8. 32 cut in half is 16. That'd be your answer. Okay? One more like that. Okay, so x plus 3 is also linear. Y equals x plus 3. Where would I start?
3.
3 on the y-axis, and then what's my slope if nothing's in front of x?
1.
A 1. So I'm going to start at my y-intercept. I'm going to go up 1 over 1, up 1 over 1, up 1 over 1, up 1 over 1. Okay, then I'm going to go down and backwards 1, down and backwards 1, down and backwards 1. Now, I'll give you a little hint. Okay, your graph has to look really detailed on these numbers, but then after that it doesn't really matter. So like when I got to -3, I'm only shading till -2. I just kind of drew the line after that. But on that interval, make sure you count the slope carefully so you know how tall stuff is. Okay, now I'm going to shade from -2 until when? -2 until 4. So I'm going to start at -2, and I'm going to shade all the way until 4. What are you shading between? The graph and the x-axis. So when you get to the x-axis, you should stop. When you get to the graph, you should stop. Now, when you look at your shape carefully, is it really a triangle? No. What shape is it? Okay, it still has a name though. It's a trapezoid. Now, someone in 4th was like, can I just do a rectangle and then a triangle on top of it? Fine, but that's what a trapezoid already is. Okay, so a trapezoid, okay, you can break it up if you want to, but a trapezoid is when you have two bases that are parallel to each other, and you find the area by doing 1/2 base plus base times height. Okay, now can you break it up into a rectangle and a triangle? Sure, same thing, doesn't matter. Okay, but I'm going to treat it as a trapezoid. Now remember what I said, the bases have to be parallel. So can this be a base and this be a base? No, it's sideways. So this is one of my bases. And then this little short side here, that's my other base. So my bases are actually, it's kind of like your trapezoid, like tipped over. Okay? So this is your other base there. Okay? Now let's count how tall the bases are. So from here to here, how tall is this little short base? 1. How tall is the longer base? 7. So I'm going to have 1/2, 1 plus 7. Now let's talk about the height. Remember, your trapezoid got tipped over. So if these are my bases, let me flip it back. Where's the height? 6. Okay, but on your graph, it's actually kind of like it's a cross. Okay? So from here to here, that's your height. Okay? 1 plus 7, how much? PEMDAS? 8. 8 times 6 is 48. Cut it in half. 24. Make sense? Yes. You're finding the area, correct. Okay? Okay. So both of those areas were above the x-axis. When you have an area that is below the x-axis, you are going to count the area as negative. Okay, now, technically is the area negative? No, but the integral is negative. Okay, so if I'm doing the next example, okay, let's do it. 2/3 x minus 4. Where would I start this graph? Well, 2/3 is the slope. Where would I start though? -4 would be here. And then my slope is going to be up 2 over 3, rise over run. So rise 2, run 3. Rise 2, run 3. Rise 2, run 3. Okay, then I'm going to also count the other way, down 2 and then backwards 3 to get other very specific points. Now, what interval are we shading on? What are my endpoints? 6 and now make sure typically the order does matter. So you'll say the bottom endpoint first and then the top endpoint second. So I would go from -3 until 6. So -3 is here. And then I'm going to shade all the way until 6. What shape is it? Triangle. What'd you say, Anisha? I didn't hear you. Oh, okay. Yeah, you have to stay between which two things? X-axis and the function. So if the function's on the bottom, it'll be on the bottom. If the function's on top, it'll form the top. Okay, area equals 1/2 base times height. What's my base here from -3 until 6? How far is that? From negative 3 until 6, 9. And then how high is this side from here to here? 6. Now, even though it's down 6, remember, the side of something can't be negative. So your height is 6. So, 9 times 6 is 54. What's half of that? Okay, but because the area was below, the integral is negative 27. So the negative signifies that the area is below the x-axis. Okay? Okay, one more like that. I see absolute value bars. What shape is an absolute value? Okay, that's going to be a V graph. Okay, so which way are we going to shift it? I see a -1 in the bars. Which way are we going? Got 'em. To the right. Okay, and then -3 would be down. Remember, the x is always the opposite. So if it says minus, you go to the right. If it says plus, you go to the left. So to the right 1 and down 3 puts me here. That's my vertex. And then you want to do your V carefully because we're going to have to count sides. So if my x is alone, then my slope is a 1. So I'm going to count up over 1, up over 1, up over 1, up over 1, etc. Now, what is my upper bound here that in my graph? So once I get to 7, I don't care. I'm just going to draw the line after that. Okay, then going the other way, when can I stop being really specific? -2. So up over 1, up over 1, up over 1, I hit -2. Now I don't really care that much. So you have to stay between which two things? The graph and the x-axis. So what that means is, on this little chunk of the graph, here's my graph, here's my x-axis. What shape would I have highlighted? A triangle where? Below. But then when I keep shading, I have to stay between. My line switches to being on top, my x-axis switches to being below. So my other triangle that I'm going to sketch ends up on top. So I end up with a little bit above, a little bit below. What were you going to say? Oh. Yeah, so you'll have 2. Yes. Because you have to stay between the graph and the x-axis. So if I want the x-axis to be a side and I want the graph to be a side, I'm trapping this little region right here. Versus this one, the x-axis is on the bottom, the graph is on the top, and I have to stay between them. Okay? So from there, what is the area of this triangle on the bottom? Okay, 1/2 base times height. My base is 6. And it does look like the height is 3. So half of 6 times 3 is half of 18, which is 9. Now, what is the area? 9. What is the integral? -9. And do we understand the difference? So this little chunk in here is a -9. You have no idea how to do what? Okay, so I just counted. So 1, 2, 3, 4, 5, 6. That's the base. And then the height is just how tall it is. 1, 2, 3. I'm going to. I just haven't yet. So this little chunk by itself is -9. We have not counted the other one yet. Yes? It is. This is if you had a graph how you would do it. So we'll learn the arithmetic way to do them. We just haven't learned it yet. We're doing graphs first. Okay, so second one. What's the base? Count it across. 3, what's the height? 3, so it'd be 1/2 3 times 3, which is half of 9, which is 4.5. Now, when I put those values together, it matters that the 9 was negative, because it's -9 and a plus 4.5. So how would that come out? -4.5. And all that the negative means is that my extra area was, more of my area was below the x-axis than was above. Make sense? Okay. So before we get into piecewise, let's do one off your homework, okay? So on your homework, we're going to do number 2, letter C. Okay, right here, this guy. The C got a hole punched out, but it was right there. Okay, so I'm going to shade for you because your graph isn't shaded well. This section. So what it says is set up a definite integral that will represent the area of the region and evaluate. So if that's the only part of my graph that's shaded, when did they start shading? Okay, from 1 until 5. And then I'm just going to write f of x here because I don't know that function. And then what would I do from there? I just compute the area. Now, what shape is that? It's a trapezoid. Very good. Remember, the trapezoid formula is 1/2 base plus base times height. How long is this long base on top? 4. How long is this little short base on bottom? Careful. Be 1, because it's from 2 to 3, right? So this one is 4. This one is 1. And then how tall is the trapezoid? 4. So it'd be 1/2, 1 plus 4 times the height of 4. 1 plus 4 is 5, 5 times 4 is 20, cut it in half, the area is 10. How much is the integral though? -10. And that's all you're doing down there. Okay? Next one, I know you can barely see it, but where is it shaded between? From 1 till 3. So what's my integral going to be? 1 to 3 f of x. Now, if you really are feeling extra, you can find the equation of the line, but you don't have to. Okay, and then what shape is that? It's still a trapezoid, but how are its bases? It's tipped over, right? So this is one of the bases, and this is the other base, and then where's the height? The side. Okay, so your trapezoid basically just got tipped over. So your bases always have to be parallel to each other. So this base is 3 tall. This base looks like it's 5 tall. And then your height from 1 to 3 would be a distance of 2. So it would be 1/2 base 1 plus base 2 times a height of 2. And then the half and the 2 basically cross out, so it equals how much? 8. Good job. So you're setting up the integral, then evaluating the integral. Okay? All right. Let me see if there's another one I want to do like that before we go on. Can I pull it? You good? A and B are shaded the whole way through. So if you want to just go ahead and do it. A is all of that. B is all of that. And then just make sure you're counting as you go. Okay? Alright, I want you to turn and do number 10 off that same homework. And then we'll go back to your notes. Number 10. Focus. Okay, Ebenezer, tell me. Number 10. What shape is the absolute value? Yes, but negative. So it opens down. What about the 2? It shifts it up. So I'm going to shift up 2, and then my V is going to actually open down because of the negative. So go to 0, 2, and then your V needs to have a slope of -1. So it's going to go down 1, down 1, down 1, down 1. And then down, 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 down. Okay? Now, where am I shading from?
From line to x-axis.
Line and x-axis, but which x's? From -2 till 4. So -2 is here. I shade, 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 fa la 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 la. Okay, then you get to 2. What happens? They switch. Who's on top now? The x-axis. So you'd find the two triangles. Remember, the one on top counts as positive, the one on bottom counts as negative, and then you'll put their areas together. So the top triangle, how long is its base? All the way across. 4. How long is its height? 2. 4 times 2 is 8. Half of that is 4. Then I'm going to put a minus for the second triangle because it's below the x-axis. Okay, how long is my base?
1, 2.
All the way across is 2. How tall is it? So it's 1/2 2 times 2. 2 times 2 is 4. Cut it in half is 2. 4 minus 2, overall answer is 2. So remember, another way to think about it that somebody else brought up that I thought was kind of smart but different, okay, is they were like, well, can't I just cross out this and then only find the area of that? Sure. Okay, if you know that these are exactly the same and they're going to zero each other out, you could do that if you like that better. Doesn't matter. Good? Okay, go back to your notes. Let's do a few little piecewise functions. So, turn to the second page. We're going to skip the top, go down to the last two. Right here. Okay, so, what is my break point for the first question? 0. So at 0, I'm going to switch from the top function to the bottom function. What shape is y equals -4? Straight line, which way does it go though? Vertical or horizontal? Horizontal. So -4 is here. I'm going to do an open circle. And then I'm going to do a flat line across like that. Okay, other side. 2x minus 2. What shape is that? Okay, it's linear. Where does it start? -2, open or closed dot? Closed. And then if it's a 2x, that means this slope's 2 over 1. So I'm going to count up 2 over 1, up 2 over 1, up 2 over 1. When can I stop counting? What x? 6. So up 2 over 1, up 2 over 1, up 2 over 1. Okay, now I'm going to give you a chance, shade very lightly. -4 to 6. Let's see if you get it right. What do you have to stay between? X-axis and the graph. So at -4, where am I shading? Above or below the x-axis? Below the x-axis. What about the next little chunk? Still below. And then at 1, what happens? You start shading above. Now keep in mind that any area that you shade above the x-axis will count as positive versus all the area that you shade below the x-axis is going to count as negative. Now how many areas am I going to have to find? 3. What are my 3 shapes? I have a rectangle, also a square, you can call it either one, doesn't matter. Okay, then you have a little baby triangle, and then you have a big triangle. Okay, so let's go right to left. Big triangle, what's the area? 1/2, how long is my base from 1 to 6? 5. And then how tall is that triangle? 10. 5 times 10 is 50. What's half of that? So my big triangle is a 25. And plus or minus? Plus. Okay, next, little baby triangle right here. I'm going to do 1/2. My base is a 1. My height is a 2. Half of 1 times 2 is? Half of 2, which is 1. And even though the area is 1, I'm going to count that chunk as a -1 because it's where? The bottom. It's below the x-axis. Okay, then last little triangle or rectangle, whatever it is, 4 by 4. Multiply it out. What's that? 16. Positive or negative?
Negative.
Because it's below. So my sum would be -16 minus 1 more and then plus 25. Negative 16 minus 1 more is negative 17, plus 25 would be 8. Make sense?
Yeah, I got it.
Okay. One more. Look at the last one. Absolute value x, what shape is that? When do I stop using it? At 2. So my v is centered at 0, 0, because it's not shifted. I'm going to go up over 1, close dot, and then stop. Then go the other way. Up over 1, up over 1, up over 1, this way. When can I stop going backwards?
6.
Well, so forward would be 6, but backwards would be negative 2. So I've already gone far enough that I'm just going to kind of sketch it after that. Okay, now at 2, I switch to the graph of 4. How does 4 look? It's going to be straight line flat across at 4. Open circle, then go across. Okay, then shade it. See if you do it right. Negative 2 to 6. Shade your graph. Negative 2 to 6. So you should have shaded here. Negative 2 to 6. Just like that. Now, is any of my area going to be considered negative? No, because it's all on top. And how many triangles are you going to have to find? 2 triangles, and then 1 square. So it's a total of 3 shapes. Now, are the triangles the same? So if you found the area of 1, really you know it for both, right? So this is a 2 by 2. So 1/2, 2 times 2 is half of 4, which is 2. Then this one's automatically 2 as well, because you can see they're the same size. Okay, then your square is how big? 4 by 4 is 16, and then just add those areas up. So 16 plus 2 plus 2, total area of 20. So this one's 2, this one's 2, that one's 16, so 20. Make sense? Okay, turn to the last page.
That was the last one.
That was the last graphing one. You don't have to graph anymore after that. What?
As we go forward, it gets worse. So I just
No, it gets better.
That's the last page.
Okay.
swear this is
Well, it's the last page, so. Okay, what is, use your brain, the integral from a number to the same number?
the same number.
Okay, let's do a graph. F of x. Here it is. You can if you want to, doesn't matter. Okay, let's say I want to integrate from 2 to 2. Well, then how far would you shade? None. Never, right? Because if I'm going to start at 2, but then I'm stopping at 2, then technically I never shaded anything, then how much area is there? 0. So the first property is that any time your integral starts and stops at the same number, it's going to be 0. Okay, the second property is when your thing is backwards. Okay, when your endpoints are backwards and the bigger number, which is supposed to be on top, is actually on the bottom, you're going to just change the sign. So you'll still find the integral from a to b, but then you're going to put a negative on it. So any time that it's instead of the correct order, it's backwards, you'll change the sign.
The sign below the answer we get?
Uh-huh. Say it again.
That we change the sign of the answer we get or the B or A?
You change the sign of the answer you get. Okay, number 3. Okay, number 3, if you want to integrate, let's say A is here and C is here. If I want to integrate from here to here, could I break up, let's change our 2 to a B. Could I integrate from A to B and then keep integrating from B to C? Would that add up to the same thing? So the third rule is that you can break any integral up as long as you start and stop at the same point. So if I integrate A to B and then I stop, but then I keep integrating from B to C, that's the same as just going A to C. Okay, next one, just like with limits, whenever you have a constant, you can just pull it out to the front. So if I have a constant K in my integral, I can pull it out, find the integral, and then multiply it after. Okay, we're going to skip Rule 5 for right now because you're not going to need it at the beginning of the next question. So, last question that we'll do today. Part A, my integral is from 1 to 1. How big is that? 0. Question 2. I want to go from 1 to 8, but the only integrals that I know are from 1 to 4, and then from 4 to 8. So I would break that up, 1 to 4, plus 4 to 8, and how big are each of those pieces? 1 to 4 is -2, it tells you that. And then 4 to 8 is 6. So I can break that big integral up into two smaller integrals and add them together. So -2 plus 6 is 4. Now, stop right there, go down to letter E. If the integral from 1 to 8 is 4, what will the integral be from 8 to 1? -4. Because why? Because it's backwards. 8's on the bottom, it's supposed to be on the top. So if the regular integral is 4, then the backwards integral would just be -4. Okay? Then let's do D real quick. From 1 to 4, how big is it? 2. -2. Then how much would it be from 4 to 1? Change the sign? +2. Then what do I do with this extra 2 in the front? Pull it out to the front. So I'd have 2 4 to 1 of f of x, but this would actually be a +2. Because why? Because it's backwards. So if it's originally positive, being backwards turns it negative. But if it's originally negative, being backwards turns it positive. It just changes the sign. So your total answer would be 4. Okay, the last rule, it looks confusing, but it's not. Just says that if you have an integral, you can add the integrals separately. So like if I was doing that top one, I would break that up into 1 to 8 of f of x plus 1 to 8 of g of x. And then how big is 1 to 8 of f of x? We already found it. 4. How big is 1 to 8 of g of x that's given to you? 10. So if that one's 4 and that one's 10, and they're together in one integral, then I can separate them back up and just add the answer. So I'd get 14. What would I get for f then? -14. Make sense? Okay, we have like 10 minutes. So pull out your homework and we'll go over whatever questions you have. Yes? You got it? Okay. And then we'll finish this last one as a warm-up tomorrow. And look at your homework for a minute. So only 1 and 2 are due tomorrow. Homework 3 is due next Friday. Homework 1 or homework 2 for number 12. Huh? Okay, any questions off homework 1? Any questions off homework 1? Nope. No? Homework 2? Okay, which one? Any of them? The whole thing? The whole thing? 6? Okay. Turn to number 6 on homework 2. Number 6 on homework 2. Oh, I already did 6. Okay, that's a calculator question. I have a calculator, so I'll just do it up there if you don't have one.
Sure, Miss. Thank
to help.
Okay, so the first thing that you should notice. Okay, what did they give you? What function for number 6? Isn't this what you picked?
Yeah.
On homework 2. Okay, they gave you acceleration. They asked you to find velocity. What do? Yassine? What should I do? Huh? Yep. What's the antiderivative of acceleration? Velocity. What's the antiderivative of cosine? Sine t plus c. Okay, then look through it. What did they tell you? At time 0, what's the velocity? So v of 0 is 2. Well, then you just plug it in and find your c. Yeah. So sine of 0 is 0, then c is automatically 2. So at that point we know v of t equals sine t plus 2. Okay, next question says, use your calculator to find v of 3 and a of 3. Okay, why can't you do them by hand? Because what's the cosine of 2, right? You don't know it, but you have a calculator. So I'm going to do v of 3 first. So v of 3 would be sine 3 plus 2. Let's figure out what that is. Sine 3 plus 2 is, you would keep it in radian always for the whole AP test. So that'd be 2.1411. Okay, next I want acceleration at 3. That means I'm plugging into this, cosine t. So I want the cosine of 3. Can't do that with the unit circle, but you can do it with your calculator. Negative 0.9899. Okay, then it asks, is the speed increasing or decreasing? Well, velocity came out positive, acceleration came out negative, so we know that it's decreasing. Next question asks you for position. How do you find position? Okay, yeah, take the integral of that one. So integral of velocity is position. What's the integral of positive sine? Negative cosine t. What's the antiderivative of 2? 2t plus c. And then remember, they had to tell you something for you to find c. So they said at time 0, the position is 5. That means that x of 0 must be 5. So 5 is the answer when I plug in 0. Well, 2 times 0 goes away. What's the cosine of 0? 1. So I have 5 equals negative 1 plus c. Then add your 1 across. C has to be 6, because you're adding it. And so then I would just come over here and adjust my equation. Remember, you can just cross it out if you want to, especially since it's homework. Okay. Another one, yes?
Can I get the homework?
Yeah, 1 or 2. Sure.
Yeah, I can't find it. I was here. You saw me. You yelled at me. Shut up. Okay?
So sassy. Another one? 5? 5 takes forever. Fine. Okay, number 5. What did they give you? Position. How do I get to velocity from position?
What question are we doing?
Number 5. Okay, if I have position and I want velocity, then I need to take the derivative. What's your hint? Product rule. Okay, u will be t minus 1 cubed. V will be 2t minus 3. What is u prime if it's t minus 1 cubed? 3t minus 1 squared. And then chain rule, the middle, t minus 1, the derivative is a 1. So you can put it or not, it doesn't really matter. Okay, what will v prime be? 2. Okay. So from there, Okay, it asks me to find velocity. I just do a cross product and I'm done. V of t equals x prime of t, which is, and then I'm going to do this diagonal first, but remember it doesn't matter. So I'd have 2t minus 1 cubed plus 3t minus 1 squared times 2t minus 3. Okay, now when I want the particle to be at rest in part B, what do I set it equal to? 0. And what can I take out of both of these terms? T minus 1, I can pull out squared of that term. So t minus 1 squared is going to come out. What's going to be left over from the first term? 2 and an extra t minus 1. What's left over from the second term? 3 and a 2t minus 3. Now remember, you cannot say, oh, these are my 3 critical numbers. No, you have to work this out to look like a factor. So that's really a 2t minus 2 when I distribute. I'm just going to write it kind of little. And then that's a 6t minus 9. So how many t's are really in there? 8t minus 11 and a t minus 1 squared. So what are my 2 at rest points? 1 and 11/8. Number line. 1 is smaller than 11/8. Smaller than 1, I could pick 0. 0 minus 1 squared is positive, but 0 minus 11 is negative, so that's a negative. And what do you notice about your 1? Double root, so it's going to stay negative, then turn positive. So when is it traveling to the left? 0 till 11/8. So that whole chunk. Okay? And then the bell's about to ring. But just real quick, when you find acceleration, what are you doing to velocity? Derivative again, and what do you need to use? Product rule. Great job. Yes? That would be a second. So you would have taken derivative. So remember, yeah, velocity is decreasing when it's negative. What is velocity slope called?
Okay, I'm not doing it.
So if you want velocity decreasing, you want to have a negative derivative. That's an acceleration. Now, traveling to the left would be the 0 where it's position. But for part C and D, you should do a second. Oh, yes, that's actually right. That's right. So your critical numbers would be 1 and 5. Velocity will be decreasing on the
You're gonna have your number
and then C decreases.
That's not what she was trying to say. So like we just don't want
You need to find your C though before you can.
My sister had to ask
And
me.
look here, it
Why the hell
says
would I
the
beg
initial
somebody else?
velocity is 24. So V of 0 is 24. And then it says at 1 the position is 20, then the position at 1 is 20. So you'll use this one to find your first C. Don't forget to label it. And then once you find that and you need to take the integral again, you'll use the 120.
And how do I find the position like E?
You'll do the integral of velocity.
Okay.
So to get to velocity, you integrate acceleration. And then to get to position, you need to integrate your velocity
Okay.
function.
Okay.
And then that's where you'll use your 120.
Good.
Make sense? If you need more help, I'll be here after school.
Okay.